Good morning, good evening, or good afternoon, depending upon where you are in the world. And welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, your moderator for today's event, and I welcome you. We have a great webinar on tap today. Lots of really great information, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to watch it again on demand. We will be sending out an email after today's webinar that will include a link to the webinar on demand. And then we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our panelists, please don't wait, don't hesitate. Just use your GoToWebinar control panel, submit your question, and we'll take about 10 or 15 minutes near the end of the presentation and go through those questions. Okay, great. Let's go ahead and kick off today's webinar, which is Develop Mainframe Software with Open Source SCMs and IBM Dependency Based Build. That's a lot to say, but it's a great webinar. We are talking today about accelerating software delivery in a multi-platform or hybrid DevOps environment. You know, enterprise customers who depend on IBM Z to run mission-critical applications, they recognize the need for an integrated DevOps toolchain. So IBM and its partner Git are doing continuous development to enable customers to standardize their development tools across the enterprise. So with that, we have two great speakers who can speak just specifically on that topic. We have Suman Gopinath, who's a worldwide architect for IBM, excuse me, in the Z series. And we have Phil Holloran, who's a solutions engineer at GitHub. You guys are getting me all choked up here. But welcome to you both. I really appreciate it. Appreciate you joining me today. And Suman, I understand that you are going to be, no, Phil, I can't remember who's going to get started today. I'm so sorry. I thought it was you, but then I said, well, maybe not. So anyway, I'll shut up and let you get to it.
Thank you, Charlene. So hello, everyone. Thank you for joining this webinar. Phil and I will be taking you through this webinar for developing mainframe application software with open source SCMs like Git and using IBM Z Open Development. We will give you a brief intro to bringing DevOps practices to Z and why modern SCMs are an integral part of that. We will also have a fun demonstration to show you that we really mean what we say. And after that, we will still be around to answer any questions that you may have. So getting started. As most of you are already aware, the mainframe has been the core of large banks, insurance companies, retail, and other major industries, reliably running their businesses and transactions for years. And what we see is that even with digital transformation and the cloud, mainframe continues to have a steady increase in its workload and continues to actually drive all of the global economy of all the major institutions around. So now what about GitHub? What does GitHub have to do here?
So GitHub is the home of the world's software developers. We are very proud and honored to be the largest developer community on the planet, with over 33 million developers across the world participating and joining us from over 2.2 million organizations. GitHub's been around for about 10 years, and as we've continued to grow the number of contributions and open source and closed source repositories on both github.com, as well as our enterprise self-hosted product, GitHub Enterprise Server, it allowed us to continue to increase the amount of code that is collaborated on among these different organizations, with over 1.1 billion contributions existing just last year. That results in over 200 million pull requests and a lot of API traffic across a lot of different repositories and projects on GitHub. And what we've seen as IBM and as GitHub throughout industries, whether they be finance, healthcare, and large companies, small companies, is that there continues to be a push toward hybrid architectures. So whether those be large integrated digital enterprises or small startups, the push to hybrid architectures spans a number of different types of systems. We see hybrid architectures in terms of enterprises utilizing both public and private cloud environments, as well as SaaS, IaaS, and on-premises deployments. We see utilization and continued growth of the distributed platforms, but also of mainframe platforms like ZOS, as well as continued adoption and participation in both closed and open source software across the enterprise. So as that continues to grow, we also notice that there's a bit of a paradox, or a bit of a kind of a conundrum that enterprise development falls into. With the continued embrace of Agile and DevOps practices on the distributed side, there's a heavy emphasis toward innovation at speed. How do we quickly introduce small iterative changes into the code base and into production to minimize the overall risk of deployment and to allow developers to quickly and iteratively deliver additional value to the business? This seems to stand in opposition to the reliability and the control necessitated for those back-end mainframe systems that power the economy, that absolutely can't go down and don't have the option of failing at all, nevertheless failing fast. So what we're going to focus on today is, how do we get the best of both worlds? How do we get the speed and agility of those DevOps practices and combine it with the reliability and control demanded and required of our mainframe environments to bring those collaborative development practices into mainframe development? And Saman?
Sorry, I was talking on mute. What does bringing DevOps practices onto the mainframe mean for all these large customers and industries? So it essentially means that you can bring your code changes much faster into the market. So you reduce your cycle times. You don't have to go back and say that, okay, there's been a change in the mainframe system and we can only probably release it in 3 months or 6 months. You can actually make sure your business changes come in much faster, and you can do this because in the course of bringing DevOps practices, you will streamline, automate your processes, bring in automation to your code review, your deployments, you'll be able to test your changes much faster and have feedback at all times. So what this also means is that you will know exactly what change has gone in why. And so from a knowledge transfer, from a documentation perspective, you do not really have to look at a piece of code and say, okay, now why did this change actually get there? Because, bringing all the DevOps practices means that you know exactly what's gone in, why, and how it's been tested, and the whole history of it all. Now, for legacy applications on Z, what this also means is bringing in automated analysis tooling also ensures that you have that vast, the vast knowledge of your businesses stored, and you're able to run automated impact analysis on these systems using tools like ADDI, which is application discovery, etc. Now, most importantly, when we talk about the large mainframe applications, we also talk about the actual personnel, the talent, the developers needed to maintain these applications. Now, there is this so-called inhibition for working on mainframe because developers out of universities and colleges don't really know, and they think it's a completely different world. So bringing DevOps practices, and so along with that, all the modern tooling also ensures that developers out of universities can easily work on these applications, and they can work on mainframe applications just like they would work on their distributed applications, because their tooling is similar, because the whole work environment is similar. You have similar SCMs, the way you do development, and so on. Now, at the heart of all this, it also becomes, when we talk about DevOps, it also becomes really important that, to be more agile as an organization, you would need to be able to make changes parallelly so that you can bring in new business changes one after the other. Right now, if you look at your current tool stack, most organizations have a completely disparate tool stack between the mainframe and the distributed systems, right? So, and this in fact goes back to my earlier point where developers can come in and they get kind of inhibited working on thinking, okay, so is this what mainframe software development is about? So what we'd like to show you today is how we can really bridge this gap by using modern SCMs, by bringing in parallel development, by letting developers work very similar in both the mainframe and the distributed world, and actually bridging in that gap that exists today.
And so we're going to do that by using a number of common tools, as we've discussed. So the first common tool that we're going to be using is IBM's Open Development, which is a series of capabilities built into a familiar Eclipse interface that allow for developers to interact directly with Z environments. We're going to be using Git as our source control, and we're going to be using GitHub as our way of facilitating the communication and collaboration among the different developers and enforcing policy. In this case, we're going to be using the self-hosted GitHub Enterprise Server product, which allows for behind the firewall deployment of these capabilities. Similarly, you could use the same github.com as well, up to you. We're also going to be using Jenkins to manage our CI and CD workflows. And this can be the same Jenkins master that is running your distributed workloads. And there's a Jenkins slave that's running out on our ZOS environment that manages that communication. We're going to be using Urban Code for deployment. Again, this can be the same Urban Code that is used to deploy your distributed code into cloud environments and on-premises environments. In this case, we're using Urban Code to deploy to ZOS. And of course, we're going to be using ZOS as our deployment target. And ZOS can run, of course, on mainframe hardware. But today, we're going to be deploying into ZOS running in ZD&T, or Z Development and Testing Environment, which runs as a virtualized environment on top of commodity Linux hardware, which allows us to get those development and test environments that we need to quickly and iteratively run automated tests and provide feedback to developers. So why Git over the host-based SCM? Well, first and foremost, Git is distributed. What that means is that developers get a copy of the local repository on their machine, complete with history. This removes the single point of failure, as we now have a number of places that we can recover from. And it also gives ZO developers the opportunity to work offline in a context. Commits can be, modifications to the code base can be made, and commits can be pushed to the local repository without a connection back to the network. We only need that connection back to the network to go ahead and actually initiate builds and start interacting with the mainframe environment. We also get the ability to perform lightweight branching. And branching is really core to working in a distributed source control and working within Git. And it's really powerful because it allows for developers to work in lots of different isolated environments with small units of change without impacting the work of other teams. Git, as we had mentioned earlier, we want to really focus on a common tooling across the development process. And outside of mainframe development, Git has really become the de facto standard for source control in application development.
So why Z Open Development? So Z Open Development, or IBM Z Open Development, is an ecosystem of capabilities that enables developers to get most out of a modern SCM like Git, and for standardizing on true parallel development across the enterprise. So ZOD helps you to work with mainframe application source that is stored in Git, and at the same time, it also includes something called Dependency Based Build. So what it does is it allows you to essentially have a build toolkit, which you can use to build your applications, analyze the dependencies required for build. Now, what you can also do with DBB is it includes Groovy for automation. So it actually helps you to bring your mainframe processes into more of an open source world. So you can hook up your mainframe processes to CI/CD open source tools like Jenkins and so on and so forth. So overall, ZOpen development is this entire set of capabilities that allow you to embrace DevOps really quickly. So why would you use Git and dependency-based build as against a traditional host-based SCM? So to start off with, when we talk about deploying more changes faster, we need really true parallel development. And when we say true parallel development, that means giving the developer the autonomy to say, okay, I want to be able to create branches to isolate my changes. I want to be able to have freedom from predefined streams. So predefined streams that say, okay, you have an integration or you have a pre-prod, and this is where you need your changes to go into. So all the predefined streams restrict you from having isolated spaces where you can store your mainframe changes for one feature after the other. Now, in addition to all, with DBB, it allows you to actually bring in the essence of DevOps, which is to have a continuous improvement process. So you can go back into your build process, you can easily improve it because your build processes can be run out of Groovy. So you can end up bringing in a lot of automation easily. You can, if you want, you can put in automated builds, code reviews, as and when you want for your specific teams, you can keep doing that. You can use generic artifact repositories like Artifactory or Nexus, and eventually, you can integrate everything into your CI/CD pipelines really easily. So essentially, it really helps you and helps bridge the gap on the parallel development which exists today in Z, and what actually is parallel development when it comes to when folks working on the distributed systems are used to. So that's where the true isolation comes in.
And so where does GitHub come into the picture? We're using Git as our open source control system for managing our code. And just as ZOD provides a level of capabilities for interacting between Git and ZOS, GitHub provides a number of additional capabilities on top of the core open source Git that are essential to embracing these development workflows. First and foremost, GitHub allows for developers to search and discover other code that's been written within their enterprise. One of the things that we most commonly see is that it's a lot easier for developers to either start from scratch or to find code samples out on the internet, whether it be on github.com or Stack Overflow or an IBM help page, than it is to often find code that's been written within their own environment. And so this allows for developers to search and find and discover and use and reuse code within their trusted development environment within their enterprise. It also enables a number of collaborative workflows on top of Git so that we can involve all of the different stakeholders and reviewers necessary in order to approve, deny, review, and eventually get changes sent and shipped into production. This provides us a lot of end-to-end traceability, and we're going to see that in the demonstration in a little bit, where we have an issue that is the source or the initial report of a bug or request for a feature that goes into a pull request where we fully document the conversation and decisions made, which are linked to the code and eventually, of course, linked to the branch that's deployed into development and then into production. A lot of those processes are automated directly within GitHub, and it also allows us to integrate with other tooling for further automation, as we'll see GitHub working with Jenkins, which pairs up with ZOD and with the ZD&T environment to get everything deployed. So what we end up with is ultimately the cross-platform enterprise tool stack. As Saman was talking about earlier, there's no need to maintain a separate tooling set for the mainframe developers versus those that are distributed. It just becomes software development and software development tooling, with ZOS being another deployment target and COBOL and other languages being other languages that developers write in. This allows for, again, that cross-training of developers on familiar tooling so they don't have to learn everything all over again. They only need to learn the key components necessary for mainframe development. So what we're going to do now is we're going to move on into a demonstration and show what this looks like to take a change from a request for a change, get that change coded up, pushed into GitHub, automatically tested, and then sent off into a pre-production environment. So let's go. We're going to go ahead, and Suman's going to start that off for us right now. So Suman.
Yep, thanks, Phil. All right, so what you see on the screen is the Z Open Development IDE, right? So it allows you to easily interact with Git. You can clone in your Git repositories in there, and you can also interact with your ZOS, so your mainframe systems, your DB2, so on. So at the bottom, you can see that I've also connected into GitHub, and you see there's a enhancement request that's raised in my name, and this is basically to, make one of the error messages returned more descriptive. Now, on the left, what I have is the healthcare application that you saw that's been cloned into my repository. Now, if I have to make a change, like any good developer, I'm going to create a new branch. So I'm going to go ahead and do that, create a new branch. Let's say I call it a feature for changing the message. And at this point, what happens is I get a personal branch where I can add in my changes. So now I can go in and let's say I want to make changes to a particular program to change this error message. Now, the ZOD editors also allow you to run, program control flows for COBOL programs, etc. So now if I open the control flow, I can get a very basic view of the program, what it does, okay, it's getting a patient data, it's got some error messages. Now, one of the interesting things about this is it's also got a feature that allows me to trace in the data flows. So I can go in and say, okay, I want to trace the data flow of a message because I want to know where all the messages are getting populated. And if you look at this, it shows me every message that's getting populated into the output. Now I can then go into the exact message that I want to go change. So I'm going to go in there and I will say, just for the sake of the change, I'll say no patient data was returned today. And with this, I make my code change and then I save the program. So now I can then go in and submit what is known as a DBB or a dependency based user build. So what does this mean? This means that I am now going to do a build of this program into my own personal PDSs, where you see the high-level qualifiers there. I can discover what is the additional copybooks, etc., that is needed for this particular build. And all this is copied over to my ZOS system, and there is a build that is run. And you can now see that the user build is complete. And I can go in, and this will be a very familiar screen to mainframe developers. It's your compile listing. I can make sure that the compilation is all fine. But what you also see is that I have also run some unit tests along with the build. So I have a Kix program, and I have unit tested it by stubbing out all Kix statements. And I did that even before checking in my code, right? So if I open my unit test cases, I see that I have a test and then it's passed. So at this point as a developer, I know that with the build, even my unit test cases have passed. And I know all this before I even commit my code change. What I can also do is I can run software code analysis to ensure that I haven't added it in any bad quality code, right? So here it tells me I haven't added anything bad, which is new. So I have compared it against the baseline. So this is the baseline, which has some errors, and I don't want to go fixing somebody else's. So I've just compared it against the baseline. I know I haven't introduced any new fix. And at this point as a developer, I think, okay, I am now ready to go in and check in the code. And once I check in the code, you see that there is, I can see that there is a new branch that is in GitHub. Now, at this point, what I can do is I would like to raise a request to merge this into an integration. And what I'm going to do is raise basically a pull request, which will start off the process of merging my change into the integration stream, or the integration branch rather. So now I'm going to go ahead and create a pull request. Now, Phil will explain in detail about what the pull request does. But what you will see is that when this was raised, automatically there were reviewers that were assigned to this pull request. And what has also happened with this pull request is that there is a Jenkins pipeline that's been automatically kicked off. So if you look at this, you can see that this pipeline has been kicked off with the GitHub pull request. And in this pipeline, what I'm essentially doing is I'm running, I'm checking out the source code from Git, the new branch. I'm running a build. I see that there's as you can see, there's a new file. That's a file that I change, and I'm running a build. The build is clean, and I'm actually creating a deployment artifact. And then what I'm also doing is I am deploying it using Urban Code Deploy. You can use Urban Code Deploy to deploy, your mainframe, your DB2, Kicks, even your distributed system into your distributed systems. I'm waiting for feedback. I know my deployment's run. And after the deployment, I've also run some tests here using rational functional tester to make sure that my regression tests are fine. And at this point, I have like a successful pipeline. So what's happened to my pull request?
So now I am coming in, and as a member of that QA COBOL team, I've been requested to review. Going down, I can see that I don't have the ability to merge that pull request yet. We have a green check from Jenkins, everything passed, but a red saying that code owner is required to review before this change can be approved. I'm going to go ahead and click to add in my review. And when I do so, I'm brought to a diff view, which shows me the proposed changes. I can comment on any of the lines. In this case, we'll go ahead and leave Suman a little bit of feedback saying, thanks for updating this line, and I'm going to start that review. If there are more files, more lines of code to review, I can go in and drop in additional comments throughout. And when I'm done, all of my changes are queued. I'm going to go in and just leave a general summary, say that this looks good to me, add in a little picture of a ship to say I want to ship it. Then I'm going to approve this, which will change that green, and I'm going to submit my review. As soon as I click on Submit Review, we're going to see that all those changes have been approved. Everything is green. And now when we switch back to Suman, Suman is going to be able to go on in, see that her pull request has been approved, as noted by that approved word right there. Jump on in. Scroll on down, we see the full review history, all of the conversation that occurred around this proposed change, and then go ahead and merge that in. With that merged, if we scroll back up to the top, by saying that this resolves that issue, we're also automatically closing out the issue that was initially raised that led to this proposed change. So what have we been able to demonstrate through this? Well, we've shown that we're combining a lot of those Agile and DevOps practices inherent within distributed development, the speed that's necessary for that, within a mainframe environment, while still having the reliability and the control and all of the gates and necessary checks and reviews that are necessary to get that into a pre-production environment. We then can follow a very similar process, put in some additional testing, additional gates and approvers before we move that up into production. We're using continuous integration and continuous deployment practices, making sure that automated checks are running on our code, that automated repeatable processes are getting that code deployed into production, and then that the logic of that code and that deployment and that automation is code. It's those Groovy scripts that live right in the repository. We're bringing in a collaborative coding experience where I'm able to mention Suman, mention a team and get those teams automatically required in for reviewers. And maybe most importantly, we're using that uniform tooling across the distributed environment and mainframe. So I don't need to know lots of different tools and processes to be able to contribute to the core mainframe code base of our enterprise. There's a lot more that we're working on, and we are excited to continue to share new learnings around this. And so Suman is going to discuss here a little bit about an upcoming webinar for additional information.
So on the February 5th, we have a webinar that tells you how you can migrate to Git using ZOpen Development. And as you can see, ZOpen Development provides Rocket's a port of Git, bundled with eGit, and the dependency based build, the whole works. And the webinar will tell you how to do the migration. So if you think you have a traditional SCM, where you have stages and streams. How do I relate that to branches? How should the structure be? And all those questions will be answered if you log into this webinar. I see that there are already 2 questions, which is on this, on how to actually migrate to Git, and whether the Rocket software is involved, is required to be installed. So yes, all this is what will be discussed in detail in this webinar.
And the link to this webinar, as well as links to additional resources about the tools that we're using today, are going to be available after the webinar in the webinar notes and the presentation that will be made available to everyone. So with that, we'd like to open, we're going to start taking and answering some of the questions that have come in. And for that, I'll kick it back over to our organizer.
Yeah. So we've got some really great questions that have come in so far, but we've got plenty of time for questions, guys. So please don't be shy. Go ahead and get your questions in. We're going to go ahead and start taking the questions now. The first one, actually, Suman just kind of alluded to. The first question: is it needed to install the Rocket software Git on a mainframe, or is it possible to do all the work without doing any install on the mainframe?
So I can answer the question. So there is a bunch of mainframe installations that will be required. One would be the Rocket Git, of course, and all this is included with the Open Development, by the way. You will also need to install the dependency based toolkit and the host component that allows you to connect into the mainframe. So yes, there is a combination of both the mainframe and your workstation install.
Excellent. Okay, next question. How did the source from ZOS get into GitHub in the first place?
So again, this would be something that would be talked about. The migration of the source code from your existing mainframe SCMs into Git would be something that will be talked about in detail in the upcoming webinar. So there is a migration process, yes.
All right, great. Let's see, next question. Is the automated testing based on ZUnit, Z-U-N-I-T? Z-Unit, yeah, sorry.
Yes, so yes, the initial, when we ran the dependency based user build, I've included the automated unit test, and that was based out of ZUnit.
And then, of course, as the Jenkins pipeline was running, we're running all of those unit tests as well as any additional tests that are integrated, that you want to integrate into that process.
Yes.
Okay. Great. There's some really great questions that are coming in. Next question: does a developer need to learn or use Groovy or Ant scripts for building pipelines and automation? For building pipeline automation.
Okay, so if the question is more on the Jenkins pipelines, there are multiple ways of doing it. So there are ways where you could have Jenkins jobs and you can figure in, but the Jenkins pipelines as such are built on Groovy, and they give you a lot more flexibility when it comes to doing a lot of automation work. Now, when it comes to the actual DBB build, the DBB build can be written in Groovy scripts. So whoever is a build administrator will be able to, write your build Groovy scripts. And the good part about this is that anybody with, Groovy being a very popular language, anybody with that knowledge would be easily able to write the build scripts. And in addition, you will also be able to even submit JCLs from Groovy and all that. That's the whole part that's available with the DBB Toolkit APIs. It allows you to have to run a lot of ZOS.
I think that's
commands.
And I think that's a great point. That whether we're talking about distributed DevOps or mainframe DevOps, there isn't a requirement for every developer to understand the build scripts in Groovy, but there is an opportunity to help improve them or propose changes to the build. So it is typically that build administrator DevOps admin type person who's setting that up initially and gets that up and running. But then the opportunity to collaborate and propose on incremental improvements to that is open to those who wish to participate.
All right, great. I am loving these questions, and we've gotten so many in, but as I said before, still plenty of time. If you have a question, go ahead and use that control panel, get your question in. Next question, what is the difference between Z Open Development and IDZ Enterprise Edition?
So the dependency based build capabilities are also available in IDZ Enterprise Edition. Now, Z Open Development, as you can see from the page just before this one, it actually includes within it the rocket port of Git and eGit along with it. Now, you can use the same thing. You can use dependency based build, and you can use Git, everything with IDZ Enterprise Edition as well. DBB comes with that, but you will have to, on top of that, install the eGit and port the rocket Git. ZOD brings everything together. But essentially you can use IDZ-EE also if you have that for working with Git.
Okay, awesome. Next question, does this have any integration with the open source mainframe Zowie? I know I'm not pronouncing that correctly. Zowie project, ZOWE project.
Okay, so Zoe is an open source initiative, well, you can integrate anything with Zoe. So you can actually, if you want to run some scripts, some CLI scripts from Jenkins, you can go ahead and do that. But dependency based build as such is separate from Zoe and is used for building. You can use it for building pipelines because of the Groovy, so on and so forth. So, yeah.
Okay, awesome. Next question, do we have to use IDZ or ZOD to use DBB? Can we bypass those IDEs and just script and call the Groovy via Jenkins?
I'll take maybe the first part of this, Simon, and certainly can follow up. As a GitHub employee, I am not a skilled COBOL developer, and I don't have all of the necessary tools running on my local machine to be able to do this. So when I'm working with COBOL, I can use a text editor or anything else and commit everything in and let Jenkins run all of the jobs for me without having to run it on my local machine. But I do lose some of that richness of the experience that Simon was illustrating within ZOD and IDZ.
Okay, great. Simon, did you want to add on to that, or should we just move on?
Yeah, so DBB is available with IDZ Enterprise Edition, ADFZ, and ZOD. So that's the only additional bit. And yes, so coming back to the Zoe question, we will be integrating with it, but yes, this is the dependency-based build, which is a separate thing. Yeah.
Okay, all right, great. Okay, next question. A migration from CA Endeavor to Git, what would be the elapsed time needed to do a full migration? And then it's in parentheses between 5-10 millions. Are we talking about years to do the job?
Well,
I hope not.
I don't think. Yeah, I don't think it is definitely not. Yes. So this along with our real life where we work with the customer for migration, we already have a white paper that's out, and that's the link to that white paper is also in this PDF. That's the tech paper that says develop mainframe software, and then you'll also be able to learn more about that in depth on the migration in the February webinar.
Okay, great. Next question. Gosh, so many questions. I'm so excited about this. Okay, is there information about how to set up ZUnit and automatic code analysis / code review on the IBM site?
On how to set up ZUnit and the code review, yes. So both the information is available in the Knowledge Center. If you go into the IBM Developer for Z Systems Knowledge Center, you will have information about both. And yes.
Okay, great. All right. So next question here. Can we use the existing eGit plugin that comes with IDZ or ZDT?
eGit, well, eGit is from the Eclipse Marketplace, and you can use that with IDZ. However, DBB is available with the IDZ Enterprise Edition.
And maybe it's best here to kind of clarify the role that both of those tools play. So eGit gets you the ability to interact with the Git repository and commit, push, pull, do all of those Git operations. And DBB is what's handling the communication between Git and ZOS to make sure that all the dependencies are in place that bring in the Groovy pipeline scripts for the automation of the build to communicate that off over to the Z environment. So you can certainly use eGit for the Git specific type operations, but it's DBB that gets you those capabilities and those APIs on top of Z to take advantage of that pipeline build script.
Okay. All right, great. Next question, kind of shifting focus just a little bit here. What are the specific roles, i.e. build admin, DevOps admin, etc., that are required to successfully implement and maintain this landscape for mainframe developers?
That's a great question.
Yes, go ahead, and then I'll
yeah, I'll take a first stab at it. So ultimately, it varies in terms of how your organization approaches this. Most organizations and most enterprises have some form of centralized developer tools team. And that developer tools team is responsible for maintaining solutions like Jenkins, like Urban Code Deploy, like GitHub Enterprise Server, and all of the necessary tools that are going to be used by both your distributed and mainframe developers. So as long as you're continuing to use those existing enterprise solutions, there's no additional responsibilities or roles on top of those who are already maintaining those tools. Then there's generally some form of build team or enablement team that is responsible for getting those pipelines set up and configured and managed for the software developers. And that'll fall sometimes in a developer tools team, or it might in a mainframe side fall on the mainframe side of the organization as like a build administrator or a build team that's supported around those. Apart from those kind of roles, those are really the specific ones that I tend to see on a large end. And Suman can speak to a little bit more of the specifics required specifically as it's related to the Z environment.
Yeah, I think that's a good summary, Phil. So so in addition, there could be a DevOps like a pipeline team that's a central team like Phil was talking about, but then you could also have like within an application a team, somebody who kind of modifies a standard set of pipeline for that application for building an automation related to that application. So in addition, there could also be the actual team that does a bit of enhancements to the pipeline based on that particular application.
Okay, great. Next question, going back to the demo just a bit, did Jenkins kick off the unit test or did DBB? I didn't see the Jenkins dashboard stepping through the build and test phases.
Okay, so the Jenkins can do the build and then run the unit test cases as part of the build after that. So the DBB is not the one, but it's Jenkins that kicked off the ZUnit test cases that ran in, ZUnit can be invoked via the US's command line, and that's what was run. So.
Okay, great. Next question, where would you place Sonar Cube code scanning?
So Sonar is a widely used code scanner. Now you could integrate Sonar and use that. So you can have your IDE use SonarLint as a plugin, and you could use the SonarQube code integration as maybe a step after the build to make sure that you've passed the enterprise level code quality standards. And that would be a step in Jenkins after the build. And SonarQube can easily pull in data from GitHub based on just a new change that you've made, and and run that through Sonar.
Yep, and just as we kind of take a look at that too, as we were looking at that pull request, when in all of those checks that were run, we can either integrate a tool like SonarQube as part of the Jenkins pipeline and have it report back as part of Jenkins here, as part of that single check, which we see right here, which is HC, UC, and D, which is our Jenkins build. Or we can break that out and have SonarQube report back separately, so that and it's really ultimately up to the build process where you want that to integrate. Is it part of kind of that global pipeline that will build or fail at different steps, or is it going to be its own separate check that's going to run?
Okay. All right. Great. So we got plenty of time for questions here. So next one, is Z Open Development open source or licensed?
It is licensed.
Okay. All right, great. And kind of related to that, how long is IBM using Git for managing its mainframe software for CICS, DB2, etc.?
So we have been internally using Git for for our internal software development. In the new the tech preview that we have, which is the Vazi tech preview, that's on the source code is maintained on Git.
Okay.
GitHub. Yeah.
Okay, great. Let's see. Next question. Does this approach, instead of traditional SCM approach, help us reduce any mainframe costs?
Okay, that's an interesting question. I think that would be a very specific question, which is from customer to customer. Overall, bringing in a distributed SCM is more for agility, and your mainframe costs are measured completely different on different parameters, and there are different other ways for bringing down your mainframe costs, and this is more to do with the agility.
I think one way to look at that would be the cost of change and the cost of waiting. So if you have to wait 3 to 4 weeks for cycle times to test your changes in a pre-production environment and get the feedback that's required, there's a cost to the delay. And using a solution like this, where we're using, which we haven't talked too much about here in the Q&A, ZDNT, which allows for those changes to be immediately tested in a ZOS environment and provide feedback, reduces the time cost associated with waiting for the available time to test those changes out and queue those into production. So while Suman is absolutely right that any sort of mainframe spend or software spend would be something to talk about specifically with your IBM and GitHub representation, we can certainly say that we would be reducing any sort of the time costs associated with waiting for that change or waiting for feedback on that change by adding all that value of getting developers that immediate feedback about what their change does or doesn't do to the system.
Okay, and time is money, so there's definitely some cost savings there. Okay, next question. Outside of IDZ, how would you trigger a DBB build from off platform?
So just like you saw in the Jenkins pipeline, the DBB build can be triggered off from a Jenkins or a pipeline. So you can
be triggered in Jenkins or from the GitHub pull request.
Yeah.
All right, great. Excellent. So next question, does DBB work with assembler module?
Yes, it does. So dependency based build again is basically a toolkit that allows you to interact with your MVS ZOS system command. So it allows you to build your assembler code as well. And I think we may have some assembler samples in our public GitHub repository.
All right, great. Next question, and let's see. Does this support natural? And it's ADABAS. I'm not sure if that's correct or not. But does this support natural ADABAS as well? And going forward, will it also cover ZOS Connect EE Enterprise Edition?
So again, the build scripts are the toolkit is essentially a bunch of APIs that's available, so you can write your own build scripts depending on the compilers you have, as long as you can invoke those and the necessary libraries using you can invoke that from the Groovy scripts for the build. ZOS Connect Enterprise Edition is used. Okay, a couple of things. So ZOS Connect EE is not a language that you will build in, but it essentially what it is, it allows you two things. One is to create, it has a toolkit that allows you to easily create APIs, and the other thing is it has a runtime that allows you to expose your mainframe assets as APIs. So you can have your assets in Git, you can have your API definitions and everything in Git. There should be absolutely no issues with that. It's not restricted by any type. So and you can deploy your ZOS Connect artifacts using Urban Code Deploy. There's no issue with that too. So.
All right, excellent. So we are just about 9 minutes to the top of the hour, so we have time for just a few more questions here. Let's see, what other open source tools what other open source tools does IBM support on the mainframe platform?
Well, there are quite a bunch of open source tools that we support. So for starters, we do have Git, but we also have a lot of languages, and we work with Sonar, which is for your, as you said, not entirely open source when it comes to COBOL and PL1, but we work with that. We can work with Jenkins. We can work with a bunch of like Spark and other things on the platform as well. And yeah, there is an entire list of open source that IBM's the platform supports, and we can add a list of that into the PDF.
All right, great. So one more question, then we'll go ahead and give you guys a break because you've answered so many of them. Last question, how can we control who can approve a change request?
I'll take that one. So what we're going to do right now is just jump right back into the repository that we were working with and take a look in GitHub how we can set up some of those policies that are in place. As an administrator in the repository, I can go over into the repository settings, and we can control a number of different things in terms of a branch-based policy. So if you think about work as branches as things that get merged up as they eventually make their way toward production, we have a number of different branch policies in place, and different policies in place for when we merge into that integrate branch, which we're using to queue up, and a different policy in place for merging up into master, which would represent our production line of code. Within this branch protection, we've gone ahead and said we're going to require a review from owners of the code, which is a capability within GitHub that lets us use a file to say which team or teams and individuals own file extensions, folders, different parts of the application that we want to be alerted to whenever a change is proposed in that part of the application. We can require those status checks to pass before merging. Here's that HCUD Jenkins build that had to pass. And then we also have the ability to restrict who can push to this branch. So if there are a certain number of people that by business policy that can't be changed or anything else that are only allowed to absolutely approve the merge, we can go ahead and add in those individuals here and say, only Suman and the QA team are actually allowed to click that merge button and fully send this code along its way to the next step of the process. What I really like about this is it allows for those development teams to provide as granular or as open a policy as required for the step of the process that we're in. Obviously getting more and more restrictive with more gates as we get closer to production, and a little bit freer if possible, while we're down in those iterative changes that are just going in and out of test, so that we can apply the appropriate level of policy to each step in the deployment process.
All right, great. Well, we are about 5 minutes to the top of the hour, so we're going to go ahead and close out our question and answer period now. But I do want to thank everybody who submitted questions. We had a ton of really great ones, and I am really impressed by the quality of the questions that came in. So thank you very much for sending those in. If we didn't get to your question, I apologize. But please know that the folks at IBM and GitHub will be getting a copy of the questions that were sent in, and I'm sure somebody from the organization will be more than happy to follow up with you offline and get your question answered. Also want to remind the audience that today's event has been recorded, so if you missed any or all of it, or if you just want to watch it again, you will be able to do so on demand. We're going to be sending out an email in a bit that will include a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so feel free to check out the site there. Just look under the webinar section, and it should be right there waiting for you under on demand. And while you're there, please feel free to take a look at some of the other webinars that we have, both upcoming and on demand. There should be hopefully 1 or 2 or 3 or 4 that pique your interest. Suman and Phil, thank you very much for your time today and for giving such a great presentation. I know the audience got a lot out of it. I sure did.
And thank you everyone for attending.
Thank you, everyone.
Excellent. Well, thank you also to the audience for attending today. And this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.
Thank you. Bye-bye.